Hello everyone, and welcome to week 3 of our course. Today I wanted to cover the main topics that are part of our DQ1, which are lists and tuples. In Python, these are known as collections, and I will also cover one more collection type called dictionary. And I also want to discuss if statements, since they are a fundamental part of any programming language. Also, since our Python assignment this week is all about numpy, I will cover this topic, along with showing you how to do this week's Python assignment as well. So let's get started. Alright, so first let's discuss the topic of conditionals, which is better known in the programming world as if statements. But before I start, I want you to pay close attention to this image on the right. The caption reads, "A Python developer measuring the level of indentation." So in most programming languages, indenting your code is optional and is only done to make the code look more organized and readable. So it's for cosmetic purposes, really. But in Python, indentation is a way of telling a Python interpreter that a group of statements belongs to a particular block of code. And a block is a combination of all these statements and can be regarded as the grouping of statements for a specific purpose. Now, while most programming languages like C, C++, and Java use the braces or the squiggly brackets to define a block of code, Python uses indentation to highlight the block of code. And whitespace is used for indentation in Python. So all statements with the same distance to the right belong to the same block of code, and if a block has to be more deeply nested, it is simply indented further to the right. So when I first started to play with Python code, I fell into the indentation trap. I thought that my code was properly indented, but my code was not behaving as expected. So, just like the picture on this slide here, I would measure the spaces of my indented code to help troubleshoot the problem. There is some humor to it, but at times it can be very frustrating as well. I guess it's a rite of passage for any new Python developer to experience this pitfall, at least once. In Python, conditional statements control the flow of a program by executing different blocks of code based on certain conditions. And here are the different types of conditional statements. The simplest form is the if statement, which runs a block of code only if a specified condition is true. If the condition is false, then the block is skipped. Next, we have the if-else statement, which extends the regular if statement by providing an alternative block of code to run if the condition is false. This ensures that one of the two possible code blocks will always execute. Then, for more complex decision making, the if-elif else statement is used. This structure allows for multiple conditions to be checked in sequence, and the program executes the first true condition block it encounters and ignores the rest. But if none of the conditions are true, then the else block runs. Alright, let's move on to the next type of if statement, which is the nested if statement. Now in Python, nested if statements are used when you need to check additional conditions within an already established condition, which creates layers of decision making within the code. And lastly, Python 3.10 introduced the match case statement, which is similar to switch case constructs in other programming languages. It allows for pattern matching, providing a clear and concise way to handle multiple possible values of an expression, each with its own corresponding block of code to execute. Now this is particularly useful for more complex decision-making scenarios where a variable might match one of several specific patterns. And we will see examples of these if statements very soon. Alright, this slide illustrates the basic structure and flow of an if statement in Python. First of all, we start with the reserved word if, followed by some condition, then followed by a colon. So the if statement is used to execute a block of code only if a specified condition, represented here by the expression, evaluates to true. So this flowchart is presented to visually explain the decision-making process of an if statement. If the condition expression evaluates to true, the program executes the block of statements indented within the if statement. These statements are executed sequentially, as indicated by the green arrow pointing from one statement to the next. Once all the statements with the if block have been executed, then the program continues with the following statement outside the if block. Now, if the condition evaluates to false, the program skips the entire block of statements inside the if statement and directly proceeds to the following statement, as indicated by the red arrow bypassing the block of code. So see how indentation is important? The block of code that will run should the if statement condition be true, that block of code is grouped together by being indented on the same level. So again, indentation is very important in Python. This slide explains the structure and logic of an if-else statement in Python. The if-else statement is used to execute one block of code if a specified condition is true and another block of code if the condition is false. The diagram here presents the syntax and flow of an if-else statement. It begins with the if keyword, followed by the condition expression. If this condition evaluates to true, then the statements within the if block, which is the indented code under the if expression, are executed. But if the condition evaluates to false, then the program follows the red arrow to the else block. Now the else block contains its own set of indented statements, which are executed when the condition is false. Now this slide also visually emphasizes the binary decision-making process. Either the statements within the if block executes, which in this case the condition is true, or the statements within the else block executes, in this case which the condition is false. And after executing the appropriate block of code, the program continues with the rest of the code that follows the if-else statement. Now this ensures that one of the two code paths is always taken, which provides a clear way to handle different outcomes based on a condition. Now this slide provides a detailed explanation of the if, elif, else statement in Python, which is a more complex conditional structure used to evaluate multiple conditions in sequence. The slide illustrates the syntax and flow of the if, elif, else statement. So it starts with the if keyword, followed by the first condition, cond1. Now if cond1 is true, then the code block under this if statement is executed. But if cond1 is false, then the program moves to the elif keyword, which is short for else if, to evaluate the next condition, which is cond2. Now if cond2 is true, then the corresponding code block runs, and if it's false, the program checks the next elif condition, which is cond3. Now this process continues for as many elif conditions as needed, and if none of the if or elif conditions are true, then the program executes the code block under the else statement. So this slide highlights several key points. Each if and elif condition is evaluated in sequence. The first true condition block is executed, and no further conditions are checked, so we exit the if statement altogether. But if no conditions are true, then the else block runs, if one exists, because it is optional. And please note the indentation presented by the tab. That is very crucial again in Python to denote the blocks of code belonging to each condition. Now the diagram uses color coding as well and arrows to clearly show the flow. So the red arrows on blocks denote the if condition. The blue or more like purple arrows on blocks represent the elif conditions. And the green arrows and blocks indicate the else condition. So this visual representation emphasizes the sequential nature of condition checking and ensures only one block of code runs, providing an effective way to handle multiple possible outcomes based on various conditions. Okay, this slide is about an exciting new feature that was introduced in Python 3.10, and it's called the match case statement. Now this addition is part of PEP 622 and brings a powerful pattern matching syntax to Python. And in case you're not familiar with PEPs, they stand for Python Enhancement Protocols. A PEP is basically a design document providing information to the Python community or describing a new feature for Python or its processes or environment. So anytime a change is suggested to Python, a PEP is created, then it's reviewed, and then either accepted or rejected. Now the match case statement is designed to provide a more readable and concise way to handle conditional logic. If you're familiar with switch case statements from other programming languages, you'll find this concept quite similar, but with additional flexibility and power. So let's look at a basic example to understand the syntax. In this snippet on the right, we have a variable named status that we're matching against several cases. Here the match keyword is followed by the variable status. We then have multiple case clauses that check for specific values for this variable. Also notice in the second case statement how we use the pipe operator to match multiple values in a single case. This basically says that if we match a case that is of a value 301 or 302, then we execute the indented code just below it. Now, some of you might wonder, why use match case instead of the traditional if, elif, else chains? Well, first, it significantly improves the readability and maintainability. The syntax is cleaner and it's easier to follow, especially when dealing with multiple conditions. Also, it provides more expressive pattern match capabilities, which can simplify the handling of complex conditional logic. And match case is particularly useful in various real-world applications. For instance, it can handle different types of HTTP status codes, as shown in our example. It's also great for parsing and processing structured data like JSON and XML, and for implementing state machines or decision trees. So we can say that match case statement is a significant addition to Python, making our code more readable and our logic more expressive. I certainly encourage you to experiment with match case in your projects and explore its full potential. And for more advanced usage and examples, be sure to check the official Python documentation. Okay, next we have nested if statements. So in Python, nested if statements allow us to evaluate multiple conditions within each other, giving us fine-grained control over the flow of our programs. Alright, so let's break down the structure of a nested if statement, as illustrated on this slide. We start with a parent if condition. This is our initial condition that we check using the if keyword. And as you know by now, in Python, after declaring an if statement, we must follow it with a colon. Now the colon indicates that the next indented block of code belongs to this if statement. And inside the block of code for the parent if statement, we can have another if statement. This is known as the nested if statement. And just like the parent if, it also ends with a colon, and the code inside it must be indented. So here we have if condition, colon, followed by a nested if condition, colon, then two statements. So this shows that statement 1 and statement 2 will execute only if both conditions are true. We can also have an else clause associated with our if statements, and the else clause provides an alternative block of code that runs when the if condition evaluates to false. For the parent if statement, we can add else, colon, then statement 3 and 4. And this means if the initial if condition is false, the code block under the else will execute instead, so running statement 3 and 4. And it's in these more complex nested if statements that indentation become very visible and crucial. Now the obvious reasons is because it defines the scope of each block of statements. Every if and nested if statement must have its own associated block of code, indented properly, or else the behavior will not be as expected. So to recap, the flow of our nested if statement can be visualized like this. If the parent condition is true, then check the nested if condition. And if that's true, then execute statement 1 and statement 2. But if false, then the code under the else statement will run. But if the parent condition is false, then we execute statement 3 and statement 4 under the else block. So the nested if statement structure helps us to efficiently create complex decision-making processes in our code. Alright, on this slide we have a series of Python code snippets that demonstrates the use of conditional statements. We begin with a variable x set to 5, and our first condition checks if x is equal to 5. Now since x is 5, this condition is true, and so we execute the indented code and print the string equals 5. Next, we evaluate whether x is greater than 4. And as x is indeed greater than 4, then this condition answers to true, so the program prints greater than 4. Following this, we have a condition that combines two comparisons using the OR operator. It checks if x is either greater than or equal to 5. Since x is equal to 5, we execute the indented code, and the output will be the string greater than or equals 5. We then check if x is less than 6, which is true, so it prints less than 6. Similarly, when we check if x is less than or equal to 5, it also prints a message as the condition is met. And lastly, we have an inequality check to see if x does not equal to 6. Since x is 5, then the condition is true, and so we execute the indented code, and the program prints not equal to 6. So these examples highlight how conditional statements can direct the flow of our program based on various conditions. Again, they are an essential tool for decision-making in coding. So far, most of our if statements have just been about one condition, but in real life, the concept of multiple conditions does exist. And so we need to translate that in programming as well. And this slide presents two distinct ways to combine conditions into a single if statements. First, we have the all or nothing approach. This is represented by the code snippet if condition 1 and condition 2 and condition 3 : In this scenario, all conditions must be true for the indented code block to execute. It's like a series of locked doors where every key must fit in order to open the way forward. So only if condition 1 is true and condition 2 is true and condition 3 is true, only then can we process the indented code. Next, we look at the only one method. Here the code reads if condition 1 or condition 2 or condition 3 : Now this is more flexible, as only one condition needs to be true for the action to take place. Think of it as multiple paths where finding just one open route allows you to proceed. So if any of these conditions is true and the other two are false, we still execute the indented code. Again, these conditional structures are fundamental in programming, and they allow us to control the flow of our code with precision and logic. Alright, now in programming, it's inevitable for things to fail, and we encounter errors. The key is to anticipate such errors ahead of time and know how to handle them gracefully in your code. The last thing you want your code to do is crash and display a cryptic message or an error-filled screen that confuses your users, right? So think of it like this. Imagine you're navigating through a maze with potential traps. In programming, these traps are errors that can occur during execution. And to safely navigate through this, we use what is called the try-except structure as our guide. Now I'm bringing this discussion up with the if statements because it's very similar, as you will soon see in the coming slides. So let's delve into the material on this slide first. We start by wrapping up a section of code with the try keyword. This is the part of our code that might trigger an error, much like a step that could spring a trap. Now if the code within the try block executes without any hiccups, then the program will continue as normal, bypassing the execute block. It's as if we've stepped over a trap without triggering it. However, should an error actually occur, then the flow of execution immediately shifts to the except block. This is our safety net, allowing us to handle the error gracefully. And whether it's logging the error or providing a user-friendly message or attempting a recovery process, the except block ensures our program can continue running or terminate safely. So by effectively using the try-except structure, we can prevent our programs from crashing unexpectedly and provide a more reliable experience for the user. Now remember, error handling isn't just about avoiding crashes, it's about creating a seamless and professional user experience. So again, in programming, we often encounter situations where our code might run into errors. These could be due to unexpected user input, unavailable resources, or simply bugs in our code. And to ensure our programs can handle such situations gracefully, we use the try-except structure. In the try block, you see the statements or code we want to execute. This is where we put our initial attempts at running a piece of code that might raise an error. It's like walking on a tightrope while being unsure if it can hold your weight. Now, what happens if our code encounters an error? Well, that's where the except block comes in. If any statement within the try block causes an error, the flow of execution immediately moves to the except block. Here, we can handle the error, we can log it, or take corrective action without stopping the program abruptly. So for example, if we try opening a file that doesn't exist, the try block will raise a file not found error. But instead of crashing, our program will jump to the except block where we can inform the user about the issue and perhaps ask them to provide a different file path. So in summary, the try-except structure is like a safety net for our programs. It allows us to catch errors, deal with them effectively, and continue running our program smoothly. Now there's more to try and except than just these two words. We also have else and finally. But let's begin at the very top again with the try block. This is where we place the code that might cause an error. It's our first attempt at executing something risky, like opening a file or connecting to a database. Now, if everything goes smoothly, the program will continue past the try block without any issues. But what if it doesn't? what if an error occurs? And that's where the except block comes into play. If an error arises in the try block, the program immediately jumps to the except block. Here we can handle the error, log it, or take some sort of a corrective action. It's our safety net, ensuring that our program can deal with unexpected situations without crashing. But in addition to try and except, we also have the else block, which runs only if no errors were encountered in the try block. It's like a reward for when things go right. So if the try block does not generate an error, then we go to the else block. And lastly, we have the finally block. This block will execute no matter what. So whether an error occurred or not, the indented code in the finally block will run. It's typically used for cleaning up resources like closing files or releasing connections. So together, these blocks form the try except statement, providing a structured way to handle errors and maintain control over our program's flow. It's an essential part of writing clean, reliable, and user-friendly Python code. And as a programmer, you need to become familiar with this approach. So you need to anticipate any errors ahead of time, place your risky code in a try block, and handle any potential errors gracefully using the combined use of the except, else, and finally blocks. Alright, I'm going to switch gear now and start talking about collections. So by now we are familiar with variables and how they are memory addresses which hold values of single items. But what happens when we want to have a variable that stores multiple values at once as one variable? Well, this is where we introduce the concept of a collection. Now think of a variable as a storage for single value items, while a collection is a storage for multiple value items. And so lists is one example of a collection. And in Python, there are three other types of collections. They are dictionaries, tuples, and sets. I will discuss dictionaries and tuples today after we're done with lists. And to define a list, you simply give it a name as with any other variable, but we follow it with square brackets, and inside these brackets, we place the different values of our data. So, as the name implies, it's a list of values. For example, you want to store the names of students, or the names of fruits, or the names of the 7 days of the week. Well, you can store them in a list. And here we have an example of a list of fruits. The variable's name is called fruits, and is set to equal a list of different fruits. Now, how do I know this is a list? Well, it's a collection of items, and in this case they are apple, banana, and cherry, and they are surrounded by square brackets, which indicate that this is a list. And the last line here shows how to create an empty list. If we just set a variable to empty brackets, then that's an empty list. And we can also create an empty list by using the list function, which is a built-in function in Python. Well, why do we need to have lists? The short answer is that there are business requirements at times that would benefit from having a list versus a group of separate individual variables. And having a list means we have items in the list. These items have attributes, for example, they are indexed. This means we can reach these items or call these individual items in the list by their index location. For example, if an item is the first in the list and I need to call it, then I would call index number 0 of my list, because indexes are always 0 based. We will see an example of this in just a few moments. List items are also ordered, meaning that they are in order, but the good news is that we can also change that order. When you are working with lists, the list items can be changed, like changing their order, but we can also change the value of the items. We can add an item, and we can delete an item in the list. In programming terms, we call this mutable, which means changeable. Another attribute of lists is that the items can be duplicated. So if you have a list of numbers or words, any of these numbers or words can be duplicated. Some other collection types do not allow such flexibility, as we will soon see. Also, the items don't need to be of the same data type. For example, one list can hold items that are a mix of strings, integers, and booleans. So we don't have to have a list that is all strings only or all integers only. And last but not least, lists come with a decent number of methods. These methods allow us to perform certain operations on our lists, and I will go through them one by one in my demo today, so you will become familiar with all of them. Okay, so I just talked about lists, and I said that they are one of our 4 collection data types. And this meant that one single variable can hold multiple values. And so dictionaries and tuples are 2 more of these collection types. And I'll start talking about dictionaries first, then I'll move on to tuples. So just like lists, dictionaries can also store multiple values in one variable. But one key difference is that instead of the square brackets used with lists, dictionaries use braces, or sometimes they're referred to as squiggly brackets or curly brackets. And you can see an example here of what a dictionary looks like. Inside the braces, we have some data, and I'll explain that in a moment. Then right under that, we have an example of what an empty dictionary might look like. We can also declare or initialize an empty dictionary by using the built-in function dict with no arguments, so just empty parentheses. Now, the main distinction of dictionaries is that they use something called key-value pairs. And perhaps the best example to illustrate this concept is just a regular English dictionary. Our regular dictionary has words, and each word has a definition, right? So this word and definition pairing logic is the foundation of dictionaries in programming. But instead of word and definition pair, in programming, we call it key and value pair. So as you can see in this example here, I have a dictionary called cars, which contains 3 key value pairs. The first key is brand, and its value is Ford. Then I have another key that's called model, with a value of Mustang. And finally, a third key, which is called year, with a value of 1964. So this is what I mean by a key value pair. And we separate the key and value by a colon, while the different key value pairs are separated from other pairs by a comma. Now, similar to lists, dictionaries are also ordered, which means they have a defined order of items, but this wasn't always the case, and prior to Python 3.7, dictionaries were not ordered. Another thing about dictionaries is that they're also changeable, meaning that we can update, add, or remove items after the dictionary has been created. However, dictionaries cannot contain duplicate keys, so no 2 items can have the same key name. For example, if you look at my cars dictionary up here again, if I add another item with a key called year and give it a value of 2023, then when I call the year key, Python will ignore the first key value pair and retrieve the second one. So while it's possible to have duplicates, Python will only retrieve the last one. And dictionaries come with a decent number of methods to help us work with them in a more efficient way. You might remember that we had a very similar slide for lists from a few minutes ago, and I will go through some of these methods in my demo. But before I do that, I also want to cover another type of collection, and that is tuples. Alright, so by now I hope you have understood the concept of a collection, which is to store multiple items in a single variable. We saw this with lists and dictionaries. And now tuples is also one of the built-in data types in Python that is used to store collections of data. And if you remember, lists use square brackets, dictionaries use braces or squiggly brackets, and now tuples use just a good old-fashioned parentheses. And in this example here, I created a tuple which holds integers from 1 to 6, and assigned it a name of top1. But how do I know this is a tuple? Well, because it's a collection of items, and they are surrounded by parentheses. And similar to having a list function and a dictionary function to create these collections, we also have a tuple function as well. And the syntax is just the word tuple followed by empty parentheses. Now, tuple items are ordered, they allow duplicate values, and they are unchangeable. Now again, the fancy word for unchangeable is called immutable. So once the tuple is created, it cannot be changed, meaning that we cannot update, we cannot add or remove items after the tuple has been created. Now to access a tuple item, you refer to the index number inside the square brackets. So in this example, if I say top index 0, I will get ABC. If I say top index 1, then I will get 34, and so on. Now you might have noticed that tuples and lists are a bit similar, with the exception of one being mutable and the other being immutable. Plus, lists use brackets while tuples use parentheses. So when should we use tuples and why? Well, tuples should be used when you have a collection of data that doesn't need to change. This will make the code more efficient and provide the program with a performance boost. For new programmers, this might not mean much, but for the program, it's a more efficient way. Now, when it comes to methods associated with tuples, there are only 2 methods, count and index. And the reason is because tuples cannot be changed because they are immutable. So there is no need for a method to add, update, pop, and so on. Now, what does the count method do? Well, it doesn't count the total number of items in the tuple. Instead, we pass a tuple item to the count method as an argument, and it returns the count of how many times this particular tuple item appears in the tuple. And I'll show you an example of that as well. If you do want to get the total count of items in a tuple, we can call the len function in Python, which is one of the built-in functions in Python. As for the other tuple method called index, it also takes a tuple item as the argument, and it returns the index position of the particular item in the tuple. Again, don't worry, I'll show you examples in a few minutes. Alright, now there's a concept in Python that is called packing and unpacking. For example, when I create a tuple, I pack multiple items into this one variable, right? The example in front of us here, I have a tuple called person, and I packed it with the values Sam, 42, and male. So I packed 3 variables into one, which is nothing new as this is the concept of a collection. Now, what I can do is also unpack these 3 variables into 3 distinct individual variables and set them equal to the name of the packed tuple as you see here. Again, I'll show you an example in a few minutes. So here's one example of if-else code. We basically start with a hours variable and a rate variable, and basically we're going to be prompting the user to enter their hours, followed by entering their rate. So basically we're going to be calculating how much a person makes, giving how many hours they work based on a specific pay rate. The if statement starts with the if keyword, again that's a reserved word, followed by some sort of a condition. So here we say if the hours are larger than 40, okay, and hours is whatever the user enters in this first prompt. So if they enter more than 40, then this condition returns true, so we enter the indented code. However, if this condition is not true, meaning that they enter anything less than 40, then the else statement kicks in, and the indented code for the else statement is what gets executed. Once that's done, then we go on to the next line of code, which is this. Okay, and this basically returns a string, says pay, colon, and then followed by the value of whatever pay is, which is calculated based on this or this. Alright, so I'm going to run this. And here, let's push this to the right. Alright, so I'm being prompted to enter hours. Let's say I work 41 hours. Hit enter. And let's say I make 20 hours, $20 an hour. Hit enter. I get $830. Okay, so that works because 41 is more than 40. So basically if hours is larger than 40, well 41 is larger than 40. So we enter this indented code. And since with the if-else statements, only the first condition that's true is run, then we don't run the else statement at all. And once we're done with the if statement, then we go into the next line of code, which is print the pay and display the pay. Alright, just like we see here exactly. These are the prompts, and then this is the return. Now if I want to try a value under than 40, just so I can test my else statement, then I'm going to go back here, F5 to run my code. I'm going to say I worked only 30 hours, and let's say I make $10 an hour, and then hit enter, and I get 300, which is correct. So it checks for if hours is greater than 40. Well, it's not, so this condition is false. Then it skips this line and then goes to the else block, and the else is a catch-all, so it runs this line, this indented code, and then it prints it out. Alright, now notice that in both examples I've been entering integers. Okay, now what happened if someone says, well, I worked 10.5 hours, or what happened if I make $10.30 an hour? So let's run that and see what happens. So let's say I worked 10.5 hours, and this happens. Okay, I get a traceback error, and the error is invalid literal for int with base 10, 10.5. So this, and it tells me, here, let me show you this. It tells me also the line 4. Okay, now if you don't see line numbers, then I can go up to the options menu and then say show line numbers. Okay, so line 4 is this, and basically it's complaining that for my entered hours, I entered a float, which is a decimal number, 10.5. And here I'm trying to convert this into an int. All right, so that creates this value error. Okay, so this is not nice to have. It's not nice to have the code blow up in the user's face. We need somehow to be able to handle this gracefully. Okay, so I'll show you how we can handle that gracefully. Alright, so this is exactly the same code that we had before. However, I took my troubling code, or the code that might give me some errors, and I wrapped it around a try and except code block. Alright, so Python is going to say, okay, let's try this code here. And if any of this throws an error, then I'm going to jump to the except block and run this code. Alright. So same exact code, nothing has changed. Okay, I'm still prompting the hours, the rate. I'm converting it over to an int because we're dealing with number and mathematical calculations. And then we're printing it out. All right, so let's run this code and see what happens now. So enter hours. I'm going to say 10.5 this time again. Now, instead of getting this error, I got a gracefully handled code that basically says, error, please enter numeric input. All right, so that's one way to gracefully handle an error using the try and except block. All right, now you could also do the else and finally. All right, so I'm going to come down here and I'll do an else, and then I'll just do a simple print statement and say we are in the else portion of the code. And then we'll do a finally, and we'll print we are in the finally part of the code. All right, so let's run this and see what happens. I'm going to enter 10 hours. I'm going to enter $10, and I get the pay. All right, and because there was no error in the try portion, then the else part ran, and then finally will also run regardless if we get an error or not. Okay, so that's how the else and finally works. Now this is when the try doesn't generate an error, but let's generate an error. So let's run this again, F5. I'm going to do 10.5, which I know throws an error. Okay, so now the try generated an error. So we go into the except block, which prints an error, and then we go to the finally block, which runs this code. All right, so that's how the try, except, else, finally works in unison. Now in the previous examples, we've been seeing some simple if-else statements with one condition. But we learned that there's something called compound conditions, where we have not just one condition to check for, but we can have multiple conditions to check for. And here we talk about the AND logical operator as well as the OR logical operator. Okay, so this code basically says I'm going to be defining three variables. X is 50, Y is 15, Z is 25. Then we have an if statement, and the if statement says if X is equal to 50, now remember the double equal sign is an equality operator. All right, the double equal sign. The single equal sign is an assignment operator, so don't confuse both of them. All right, so if X is equal to 50 and that's a logical operator, Y is equal to 195 and Z is equal to 25. With the AND operator, all three conditions have to be true for this entire definition to be true. All right, so it's an all or nothing. So is X equal to 50? Yes, it is. Is Y equal to 195? No, it's not. Is Z equals to 25? Yes, it is. So as long as one of them fails, which in this case this fails, then all of this condition will not return a true, will be a false. So we go to the else and then print this line. Okay, just because one of them is not true. So let's run this and test it. F5. At least one comparison is not true. So that means we came here, which is correct, because 195 is not true. So let's change this to 15. So now X is 50. Yes, it is. Is Y 15? Yes, it is. And is Z 25? Yes, it is. So the ANDs fulfill this compound condition, and they're all true. So if I run this code, I should get the all comparisons are true, in the AND statements. All right, so that's what the AND does when you're doing if statements with compound conditions. Let's check out the OR part. All right, so let me comment this part out. Let's bring this back in. All right, so if x is equal to 50 or y is equal to 115 or z is equal to 20. So we know that y is not equal to 115, it's equal to 15. And we know that z is not equal to 20, it's equal to 25. But we do know that x is equal to 50, okay? So the OR basically says at least one just has to be true. I could have 100 conditions to check for, but if only one answers to true, then this whole line is true. Okay, that's what the difference between the OR and the AND. AND is all or nothing. OR is just one, and that's it. All right, so let's run this code. I should get this output because 50 is true while the rest is false. But since only one is true, then I'm going to enter the indented code here. So let's run this code, and I get at least one comparison is true in the OR statements, and that's correct. All right. Now if you change this and make this one wrong as well, so this is false, this is false, and this is false. Okay, so none of them are true, and if we do that, then nothing is true. Okay, so again, that's the difference between the AND logical operator and the OR logical operator. Okay, let's start working now with lists. Now, lists is one of the collections of data types in Python. Again, we have lists, we have dictionaries, and we have tuples and sets. So this is going to be a lot of examples for lists. All right, so here I have a list defined, and I've called it fruits, and I'm assigning it these values. Okay, now how do I know this is a list? Well, first of all, it's a collection of items, and they're surrounded by square brackets. Okay, so my list includes string value apple, blueberry, kiwi, banana, kiwi again, and watermelon. Now we are allowed to have duplicates in lists, so this is acceptable. All right, so I'm going to start uncommenting some code just to see what we get back. So here's just a simple print statement. I just want to see what happens when I print fruits, and fruits is a list. So let's print that out and see what happens. I get exactly what the list is, which is just a list of items. Okay, nothing too special here. All right, I'm gonna undo this. Now let's uncomment that. Now to get a specific item in your list, you have to use the index notation. So fruits index 2 is going to get the item that's in the list that's in the third location, third index location. Why third index location when I say 2? Well, because index are 0 based. So this is index 0, this is index 1, and this is index 2. So technically it's the first, second, third item. So you have to start getting used to the index notation idea and that it starts at 0. So if I run this, I get kiwi, and kiwi is my 0 index, 1 index, 2 index. So this is correct. All right. Now sometimes you don't want just one item, sometimes you want multiple items. Okay, so now we can use index notations, but using a range for the index notation. So I'm gonna print out from my fruits list starting at index location 2. So start from 2 and then stop at 4. And if you remember also from our last week's discussion, the stop does not include the stop. Just like when you're driving up to a stop sign with a car, you don't stop at the stop sign, or you don't stop after the stop sign, you stop before the stop sign, or at least that's what the law says. So 4, which is at the stop, is not included. So if I want to get fruits index 2 to 4, then it's going to be, well, this is 0, 1, 2, so this is index 2, then I need to get index 3, but I do not include index 4. So I should only get back kiwi and banana. So if I run this, I get kiwi and banana, which is correct. So basically I'm getting a subset of the items in my list. This is the entire list, and then this is a single item from my list, but this is a range of items in my list. Okay. Now the notation also for the index, if I don't include anything in the start value, that means start at the very beginning. All right, so if my starting point is empty, that means start at index 0, and then the 4 is the stop, so I'm going to stop at 3, or technically include 3, but not include 4. So if I start at 0, I'm going to get this, and that's 1, and that's 2, and that's 3, and that's 4, but I don't include 4, so I'm only going to get these values. So let's test F5. and I get the first 4 values: apple, blueberry, kiwi, and banana, which is correct. All right. Now what happens if I switch? I specify a starting point, but I don't specify an ending point. So if you would guess, then you start at 3, or index location 3, and then since the end is not included, then, or I'm sorry, it's not specified, and then it's going to go all the way to the end. So if I start at index 0, I'm sorry, index 3 would be 0, 1, 2, 3. So I start at banana, and I go all the way to the end. So am I going to get banana, kiwi, watermelon? Well, let's find out. Uncomment this guy. Let's run it. And that's what I get. We start at index 3, which is banana, and then go all the way to the end, whatever the end is. Okay. Now sometimes you want to get the very last item, or you want to go kind of backwards. So to do that, we use a negative notation. So -1 basically means it's going to get the very last item. -2 would be the second last item, -3, and so on. All right. So -1 should return back watermelon, because that means it's the last item. So if I run this, I get watermelon. Okay. All right, let's comment that out again. Okay, now if you want to update items in the list, because you are allowed to update items in a list, because lists are mutable, then this is the notation to do it. Let's comment this one out. So the way to do it is you call the list's name, followed by the location of the item that you want to update, and then set it to whatever value you want to give it. So right now index 1, this is index 0, this is index 1. Right now this is blueberry. But if I say fruits 1 is set equal to orange, then blueberry is going to be updated with orange. Okay, and then I want to print it out just to see what happens. Okay, because right now it's apple, blueberry, kiwi, banana, kiwi, watermelon for the fruits list. After this change, I'm going to print my fruits list and see what I get back. And there we go. Now I get back the list, but it's no longer blueberry, it's now orange. So that's how you can update a value in a list. Okay. You could also loop through a list, very nice and quick. And all you have to do is do a for loop, followed by an iteration variable, followed by the in reserved word, followed by whatever sequence of items you want to loop through. So we are looping through our list called fruits, and once we do that, we print x. Now we have not covered for loops yet, so I'm just going to run it for you, and we'll explain for loops in the next week. And there we go. We loop through item by item, and we just print it out. Okay. Now it's very typical also to say, well, how many items do I have in my list? I need to find that out. So we do that using the len method. So len is basically a, well, short for length, but it's a built-in function in Python that allows you to return the length of an item. It could be the length of a word, so it tells you how many characters are in it, or it could be, if it's a length of a list, it's going to tell you how many items in the collection. All right, so we have 1, 2, 3, 4, 5, 6. So if I run this, I get 6. Okay, so that's what the len function can do when you pass it a list as an argument. Now lists comes with a slew of methods, and the very first one I wanted to show you is the append method. So let me just comment that out. Alright, so the way to do it is you call the name of the list, which is fruits, followed by a dot notation, followed by the append method. Okay, now it's a method and not a function, because the difference between a method and a function is if the method or if the function belongs to a class. In this case, fruits is a class of a list. If it belongs to a class, then we call it a method. But if the function is a standalone function and does not belong to a class, then we just call it a function. All right, so fruits.append is basically going to take an argument and it's going to append it to your existing list. So I'm going to append raspberry to my fruits list. Okay, and if you remember, fruits does not include raspberry yet. All right, so let's run this code. And let's bring this a little bit back so we can see the whole thing. And there we go. So I originally had apple, blueberry, kiwi, banana, kiwi, watermelon, and now I just added raspberry. Okay. Now, why is blueberry back and not orange? Well, because I reran my code and I defined fruits to have blueberry in it, just in case you were wondering. So that's what the append does. The append adds something to the fruits list, and that's allowed because lists are immutable. Let's comment that out. Fruits also has a copy method. All right, let's take a look at that. All right, it doesn't take any arguments, so we're going to call the copy method on fruits, and whatever that comes back as, we're going to assign it or store that value into a new variable called copy. All right, and then I'm going to basically print out the new copy list is copy, and I want also to show you that it's basically a copy of fruits, so I'm going to print out also fruits just to make sure that they're a copy of each other. So let's run that. All right, let's bring this back in again, like that. So the new copy list is apple, blueberry, kiwi, banana, kiwi, watermelon, and the original fruits list is apple, blueberry, kiwi, banana, kiwi, watermelon. So they're identical. All right, and that's what the copy method does. Again, there are a lot of methods you can apply to lists. We learned append, now we learned copy. Let's look at some more. All right, there is a method called count. And again, it's part of the list class, and you need to pass it an argument. So the argument is kiwi. Now we have kiwi up here, you have kiwi here, and I have kiwi here. Now is it going to return how many times it appears? Well, let's find out. Run it, and I get 2. Okay, so kiwi has 2 counts in the fruits list. So anytime you want to know how many times an item appears, if you're looking for maybe duplicates, then you can do that. Okay, let's comment that out, and let's bring this back in. All right, now there is an extend method. So an extend method, as the name kind of implies, we're going to extend the fruits list with items in another list. All right, so here I have a list called tropical underscore fruits. Why is it a list? Well, it's a combination of items or a collection of items, and they are surrounded by square brackets. So this is another list. Okay, up here I have fruits list, and then down here I have tropical fruits list. Now what I'm going to do is, and it has some values, and what I'm going to do is I'm going to take the fruits list, I'm going to extend it by adding whatever is inside the tropical fruits list. Then I'm going to print out fruits to see how it changed. So technically fruits now should look exactly like this, but have 2 more items extended, which is the mango and pomegranate. So let's confirm if that's correct. And there we go. After watermelon, we have mango, and we have pomegranate. All right, so that's what the extend method just did. All right, next method is insert. So you might be confused, well, why do I need insert if I already have append? Well, you might have noticed that when I ran the append method, the addition was thrown at the very end, okay, which sometimes could be fine. But what happens if you want to append it into a specific location and not just at the end? So that's where the insert method comes in. The insert method basically requires 2 arguments, a location argument and a value argument. So this insert method is going to apply to the fruits list. It's going to insert the value tangerine in the index 2 location. All right, then I'm going to print out the fruits list just to see what I'm getting back, how the fruits list has changed. So fruits right now has apple, blueberry, kiwi, banana, kiwi, watermelon, and this is the 0 index, this is the 1 index, this is the 2 index. So kiwi is in the 2 index. I am going to insert tangerine in the 2 index. Now I'm not going to replace the 2 index, I'm going to insert it in the 2 index, and then all this would be shifted 1 step to the right. Okay, so let's verify that that's the case. Let's run this. So now I have apple, blueberry, and then instead of kiwi, I now inserted tangerine, and then kiwi, banana, kiwi, watermelon just got bumped to the right. So that's the difference between the append and insert. All right. Another method is pop. All right, so let's assume you don't know what pop is, but let's run it and see what happens to our fruits list. So I used to have apple, blueberry, banana, kiwi, watermelon, but something seems short. So something went missing. All right, my original fruits was apple, blueberry, kiwi, banana, kiwi, watermelon. All right, so it looks like kiwi, which is index 2, got kicked out. Apple, blueberry, there is no kiwi, banana, kiwi, watermelon. So the pop method popped out this whatever was in the index 2 location. Okay, so that's what pop does. So pop takes a index location as a argument. Now you might not know what is in index location 2, but whatever is in index location 2 just got popped out, meaning it got deleted. All right. Now what happens if you want to delete an item by its name and not by its location? Well, instead of using pop, we're going to use the remove method. Again, I told you there's a lot of methods for lists. So the remove method, I'm going to call it on the name of my list. I'm going to pass it the name of the item that I want to remove. Now, I don't recall happy being one of the items. So let's see what happens. I get a value error. Why? Because X, which I just passed here, happy, is not on the list. Okay, so be careful when you're trying to remove an item that does not exist, you're going to get an error. So let's change this to, well, let's change it to banana. Okay, and banana is here. So I'm going to run this code, then I'm going to print out the fruits list to see if it did remove it or not. F5, there we go. There is no banana anymore. So that's what the remove does. All right, so let's move on to the next method, and that is sort. So from the name, you can guess that this is going to sort our list. So our list right now is apple, blueberry, kiwi, banana, kiwi, watermelon. So this is a list of strings. And if we're going to sort something that's a string, then it's going to sort it alphabetically. So the A is going to come first, then the B, then the K, and then the W. All right. So let's run this code. And there we go. So now our list has been sorted by alphabetical order. So the A's first, then the B's, then the K's, then the W. All right. Now there's another method called reverse. So do you think reverse is going to reverse the order? Well, let's try that out. See what happens. I'm going to run this code. And that's exactly what it did. It reversed it, but did not put it in alphabetical order because the order is apple, blueberry, kiwi. Actually, no, that's that. Well, it used to be apple, blueberry, kiwi, banana, kiwi, watermelon, but when I called the reverse method on fruits, it basically reversed the order. So whatever was last became first, whatever was first became last. So that's what the reverse does. And there will be times where you want to erase everything or delete everything that's in your list. Basically, you want to clear your list. So clear is a method that you can call on a list, and then when you print it, you're going to get an empty list. So let's try that out. And there we go. Bracket, bracket, meaning there's nothing in the middle, so no more values. So this is an empty list because we just called the clear method on it. Okay. Now sometimes you can have a list within a list. So what does that mean? Well, take a look at this code here. All right, so I have fruits just like before, and it starts out with orange, berries, but then in this item here, I have another list, and then I have an item, and then an item, and then close my list. So one item could be a collection of items. All right. So the question now becomes is, well, how do I call an item inside an item? Because this is the big list, and then this is a list inside the big list. So the way to do it is same exact way as we've been doing it up here, but not just one index location. We're going to need two index locations. Okay, so this is called a 2D list because it's two-dimensional. We have the big dimension, and then inside the big dimension we have another dimension. So now we have 2D list. So the way to call it is, now we know this is index location 0, this is index location 1, and all of this is index location 2. So I know that my first dimension is index location 2. So I start calling it like this, fruits index 2. And then say I want raspberry, okay? And this needs to be commented out. Say I want to find raspberry. So raspberry is, once I'm in this location, then now the counter starts again. This is going to be 0, this is going to be 1, that's going to be 2. Okay, so 0, 1. So then this would be index 1. So now I have 2 index locations, one for the big list and then one for the sub list. Alright, so this should return back raspberry. So if I run this, I get raspberry. Alright, so these were some of the methods. Again, lists come with a lot of methods. I think I covered most of them, but I'm sure there's a few that I missed. So please do follow up with the Python documentation on lists. And again, if you have any questions, please do let me know. Okay, so I have a notebook open here, a Jupyter notebook with a lot of examples for dictionaries. And basically a dictionary is a collection data type. Just like we have lists and tuples and sets, we also have dictionaries. Now, from what we learned already, dictionaries are basically a collection of key value pairs. So here I first created a dictionary, I called it cars. And then I know it's a dictionary because first of all, it's surrounded by braces or squiggly brackets. And then inside the braces, I basically have a combination of a key and a value for that key. And they're separated by a colon. And then the different key value pairs are separated from each other by a comma. Okay, so this is the name of the dictionary. This is my first key value pair. This is the key, followed by a colon. This is the value. And then if I need more key value pairs, then I do a comma. Then I go to my next key value pair. If I need another one, I do a comma, then go to my next key value pair. And if that's the last one, then I stop and I don't do a comma anymore. Okay, but that's what a key value pair as part of a dictionary, which is a collection data type. Now, how do we use dictionaries? How do we call them? What are the methods that apply on them? Well, to display the full dictionary, I'm just going to print it out. Okay, and if you want to, let's comment this out first. So if I run this, I get just my entire dictionary. And it's a dictionary again because it's surrounded by braces and it has key value pairs separated by commas. Alright, now if you don't want the entire dictionary and you want a specific one or a specific value of a key, then I can comment this out, uncomment this back in. So the syntax is you call the item by first calling the dictionary name, which is cars, followed by the name of the key. So brand is a key, model is a key, year is a key. Ford is the value of the key called brand. Mustang is the value for the key called model, and 1964 is the value for the key called year. Now, keys are always going to be string types, so they're always going to be surrounded by double quotes. And value, because it's a value of something, then sometimes it could be a string, sometimes it could be an integer, and so on. So values can be different data types, but the keys are always going to be string types. Alright, so if I want the value of the key model, which is Mustang, then I call it by the dictionary's name, and then in the hard brackets or in the index type notation, I don't give it a location, but I give it the actual name of the key. So cars index model, then it's going to give me the value of whatever the key model holds, which is Mustang. Alright, so if I run this, then I get Mustang. Okay, now there are multiple ways you can actually get the value of a key. So down here is another example. I have the same exact dictionary, and here I have a variable called model name. I'm going to set it equal to cars, and then there's a method on dictionaries called get. So when you call the get method, you need to pass it the name of the key. So key model is this key here. So I'm going to say cars.get and then pass it the name of the key, and that's going to get the value of this key. Then this value is going to get returned. It's going to be assigned to a new variable called model name, and I'm going to print out the model name. So if I run this, I get Mustang, because Mustang is the value of the key model. Now, dictionaries also do not allow duplicate keys. Alright, so here you can see the cars dictionary again, and then I have brand, model, and then I have year, which is 1964, and then I have year again, which is 2023. So what happens when you have multiple keys with two different values? Well, Python is going to basically return the very last value of the very last duplicated key. Okay, so cars year is basically cars is the name of the dictionary, year is the name of the key, so this is going to return the value of the year key. But instead of 1964, which is the first one, it's going to return the very last one that it has access to, which is the 2023 value. So if I run this, I get 2023 instead of 1964. So while duplicates seem to be allowed in dictionaries, only the last one is going to be returned. Let's look at the next example. Another method in dictionaries is keys. All right, so if you think keys is probably going to return the keys of my cars dictionary. All right, so let's see if that's the case. That's exactly the case. So the keys method is a method you can apply to dictionaries that basically return just the key names. Okay, brand is the key, model is another key, year is another key. All right, what happens if I want to get just the values? Well, there's another method for it called values. Let's bring this up a bit. So values is a method that you can apply to dictionaries that's going to return just the values. So let's run that and see. That's exactly what I get. I get just the values. All right. Now what happens if you want to get both? If you want to get both the key and the value? Well, there's another method called items. So if I do cars.items and I run it, I get basically this. I get the first item, which is key and value pair, another key value pair, another key value pair, another key value pair. All right. Now what happens if you also want to check if a value or if a key is part of your dictionary? Well, we can use the if statement followed by the name of the key and then the in reserved word followed by the name of the dictionary. So I'm going to say if model, which is a key, in cars. If this statement is true, if the key model is in my cars dictionary, then this is true, then enter into my indented code. All right. If not, then I don't have an else statement, so nothing's going to happen. So let's run this. And I get yes, model is one of the keys in the cars dictionary. Well, what happens if I change it to a capital M? Because we know that Python is case sensitive. I run this now. I get no output because there is no else statement. Okay, because model, the key model, is not part of cars. Because again, capital M is different than lowercase m. All right. Okay, now how do we update values in our dictionary? Well, this example here has our same cars dictionary, brand Ford, model Mustang, year 1964. Then I'm going to print cars just to see what it is. And it is exactly what it is. It hasn't changed yet. All right, let me do some changes. I'm going to comment this guy out. All right, so I have cars, which is the name of a dictionary. And then in index notations, I'm going to call the key color. I'm going to set it equal to red. But wait a minute, there is no key called color. So how can I update it? Well, with dictionaries, if you're trying to update a value for a key that does not exist, it will insert it for you and assign this value to it. Okay, so right now I don't have color. So if I do cars color equal to red, then it's going to add a new key value pair called color with a value of red. So let's test that out. Okay, so I printed the cars dictionary before the change, and then I printed it after the change. So before the change, there was no color. Then after the change, here's the color. Red item has been added. Okay, so this was the behavior because there was no key called color. All right, but what happened if there is a key called color or an existing key? How do I update it? Well, there are a couple of ways. Actually, more than a couple of ways. So one way, actually, let me get rid of this first. All right, so we can call the update method. So dictionaries have a method called update, and you pass it the actual value that you want to update. So I'm going to update body with a value of sedan. Now I still don't have a key called body, let alone a value that's called sedan. So just like we did here when there was no key with a value red, it created one for us. With the update method, I'm also going to pass it a key that does not exist and a value. So when I run that, now I have a updated dictionary with a key value pair of body sedan. So this did the trick. This also did the trick. But again, what happened if I want to update a value that exists? Then let's get rid of this. Let's bring this in. So here I'm saying cars model is equal to country. So I do have a key called model already, but the value is Mustang. All right. What I'm doing here is I'm saying, okay, take the model key, which is part of cars dictionary, and assign it a value of country. Whatever its current value is, override it. Okay, so I'm going to run this. And now initially model was Mustang, but now model has a value of country. Okay, so technically I can do the same thing also with the update method. Let me get rid of this. Let's bring this in. So just like I did an update method, but when I passed it a value of a key that does not exist, it created it for me. The same thing also with update. If I pass a key that does exist, it's going to update it for me. So model is Mustang. I'm going to change it to Galaxy. So let's test this. There we go. Model has been updated from Mustang to Galaxy. All right. Another method that we can call on dictionaries is pop item. Okay, now you might remember from list that pop usually is associated with getting rid of something. So pop item, is it going to get rid of the last key value pair? Well, let's give it a shot. I'm going to print out the original cars dictionary. I'm going to pop an item. Then I'm going to call the cars dictionary one more time to see how it changed. So let's run this. Okay, so pop item with no parameters or arguments passed basically deleted the last item or popped out the last item in my dictionary. Now what happens if you want to pop out a specific item in your dictionary, just like we did with lists before? Then we can call the pop method. So the pop method takes an argument of the name of the key. So if you want to pop out model, okay, specifically model, then you need to call the pop method, pass it the name of the key, and then I'm going to print the cars dictionary before, I'm going to print the cars dictionary after to see if key model has been gone. And yes, we used to have model Mustang, and now we don't. So pop item is going to get rid of the very last item, and pop, when you pass the name of the key, is going to get rid of the specific key. All right, and just like with lists, we had a clear method. Dictionary also has a clear method. So I'm going to print cars before I do anything to it. So it's going to return the value of these key value pairs. Then I'm going to call the clear method on my cars dictionary and then print it out again, and it should be an empty dictionary. So let's test it out. Initial dictionary is filled with items, and then I cleared it, so now it's empty. And here we can also loop through a dictionary list of items, just like we did with lists. But again, we haven't covered loops yet. So for is the reserved key, x is an iteration variable, in is another reserved keyword, and then cars is the name of the dictionary, which is a list of item or a sequence of items. So for x, for every x in cars, do this. Okay. Let's run that. And I get basically the list of keys. All right. Now I got keys even though I didn't specify keys. So here's something to watch out for. If you want to loop through cars just by the name of the dictionary without specifying keys or items or values, then just saying for x in cars is going to return just keys. But you can also call it, let me get rid of this, you can also call it by calling the keys method. So we learned about the keys method a few moments ago. So the keys method is going to return just the keys. Okay, so I'm going to loop through the key in the keys elements in my cars dictionary. So that's basically the same thing as what I did up here. So if I uncomment this out and I run this, actually let's comment this out as well and call it, I get basically the same exact thing. So when you loop through cars just by the name of the dictionary, you get keys. And when you loop through cars.keys, you also get keys. Okay, if you want to get values, you basically loop through cars.values. That's going to return values, not keys. There we go. And if you want to loop through both the key and the value, then you call the items method, and that's going to give you both key and value. So by default, when you loop through just the name of the dictionary, you're technically as if calling the keys method. If you want values, then you call the values method. And if you want to loop through just the items, then you call the items method. Now again, just like lists, there are a lot of methods for dictionaries, and I don't think I covered all of them, but please do refer to the Python documentation for more information. Okay, here's another Jupyter notebook that has a lot of examples for you working with tuples. At the very first cell, I basically defined a tuple called tup1, and it includes values A, B, C, D, and E. Now, how do I know this is a tuple? Well, first of all, it's a collection of items, and it's also surrounded by parentheses. Now, to access a tuple, we basically, very similar to lists, we call the tuple name and then follow it with some index notation. So I have a tup1 with these values in it, and then I'm going to print out some tuple index locations. So tup1, which is the name of my tuple, and then index 0 basically is going to fetch the very first item in my tuple. So the very first item is 5. So tup1 index 0, remember indexes are 0 based, so 0 would be the first item. So tup1 index 0 should return the value 5. And then tup1 index -1, just like we saw with lists, this would be basically the very last item in our tuple, which would be 193. And then we can also use range notations where we have a start and stop. So the start is inclusive while the stop is not inclusive. So tup1 index 1 to 5 would mean it starts at 1 and include index 1, but then it's going to stop at 5 and not include index 5. So index 1 is basically 22, index 2, index 3, and index 4. All right, it's not going to include index 5. So let's run this and test that out. There we go. So tup index 0 is 5, and then the very last item is 193, and from 1 to 5 is 22, 94, 4102, and 914, which is correct. All right. Now, a common thing to do also with tuples is to check if an item in a tuple exists. So here I have a tuple called fruits, and it contains the items apple, banana, and cherry. Then I'm going to create a variable called fruit. I'm going to set it equal to banana. Okay. Now notice I have banana with a capital B versus what I have in my tuple, which is banana with a lowercase b. And of course, Python is case sensitive. And then we have an if statement. I say if fruit, which is this value here, if fruit is in fruits. So if banana with a capital B is in fruits, which is this list here, which is this tuple, I'm sorry, here. All right, if so, if this condition is true, then go into the indented code and run the code. Else, if this does not answer to true, then go to the else block and print or run the statements in the else block. All right, now we could already guess that banana with a capital B, which is the value for fruit, is not the same as banana with a lowercase b. So if I run this, I should get the else treatment, meaning that the name of the fruit is not in the fruits tuple. So if I run this, that's what I get. Banana is not in the fruits tuple. But if I change the value of fruit to a lowercase b, and now it matches banana, and I run it, now I get banana is in the fruits tuple. Now from the PowerPoint presentation, you might recall that we had two methods for tuples, count and index, and the reason being is that tuples are immutable, so we can't change them. So the two methods are the count method and the index method. So here I have a tuple that contains items, integers 1, 3, 9, 7, 8, 7, 5, 4, 6, 8, 5. Okay, and then I'm going to call the count method on my tuple. So I call the tuple by its name, tup1, then a dot notation, and then the method that I want to call, which is count. Now count is not going to actually count the number of items in my tuple. To do that, you have to use the len function, which is a built-in function in Python. So count, what does it do is it takes one argument, which is a item in your tuple, and it should return how many instances this item appears in the tuple. So 7 appears 1, 2 times. Okay, so let's see what we get back when we run this. I get 2. Okay, so the count, and you pass it the item that you want to count for, is going to return how many items, how many instances this item appears in your tuple. So that's what the count method does. And the next method is the index method, and as you can see here, it also takes an argument. Now the argument basically is an item that's in your tuple. Okay, and this is not going to return the count. This is going to return the index location for your item. Okay, so I have, would be index 0, this would be index 1, this would be index 2, this would be index 3. So index 7, the method index with an argument of 7, will return the very first index location for that number. Now, why say the first? Because 7, I have multiple 7s, okay? So index 7, which is the method index, when I call it from a tuple item, that's going to return the index location. So if I run this, I should get 0, 1, 2, 3. I should get 3, which is the index location of the item that I'm passing as an argument. So if I run this, I get 3, which is correct. Index 0, index 1, index 2, index 3. All right. We also talked about packing and unpacking our tuples, or basically our collections. So here I have a variable called person, and it's basically a tuple. Why is it a tuple? Well, because again, it's a collection of items that are surrounded by parentheses. Okay, so technically I am packing a lot of information into one variable, and I'm calling it person. But then I could also go the other way around, and I could unpack my values. So basically I'm going to say, out of person, I'm going to unpack into two variables. I'm going to create a variable called name, I'm going to create a variable called age, and I'm going to set it equal to person. So when you create a collection, you're basically packing information in it, but then you have the option, if you want to, you have the option of unpacking that same information from your collection type. And then when you print them out one by one, you should get Sam for name, and you should get 42 for age. So if I run this, it's exactly what I get. I print name, so I get Sam, and I print age, which I get 42. So name is basically the output, or basically the unpacking of the first item in my tuple, and then age is my second item when I unpacked the person tuple. And we can do the same thing again with the same packing and unpacking with lists. So this is exactly the same code. The only difference is here I have brackets, as opposed to up here I have parentheses. So the difference is this is a tuple, and then this is a list. But they work exactly the same way. I basically pack a lot of information into one collection, and then I can have the option to unpack the items into new variables that I create. And then when I run this, I get exactly the same thing. In this lesson, you will learn about the numpy library. Numpy, which is short for numerical Python, is an open source library that provides support for numerical computing. It was created by Travis Oliphant in 2005 and has become a fundamental Python library for scientific computing, data analysis, and machine learning. The core feature of NumPy is its powerful n-dimensional array object called NdArray, which is designed for efficient numerical operations. Now, the NdArray is the primary data structure in NumPy. It is a grid of values, all of the same data type, indexed by non-negative integers. So, someone familiar with Python might question then, how different are NumPy arrays from Python's built-in lists? Good question. The quick short answer is that NdArrays are more efficient and faster than Python's built-in lists for numerical operations. So let's look at some code examples together. My first line of code shows that I'm importing the NumPy library and aliasing it with the term np. Now for this line to work, I must have NumPy installed. And to install it, I go to my command line prompt, and I'll type pip install numpy. Then I'll hit enter, and the results indicate that I already have it installed. But if this was my first time to install it, the output would have been different and taken me a bit more time to run. Then the next line basically calls my np object, which is my alias for the NumPy library, and I call the array method and pass it an array of integers, 1 through 5. Then I assign this value to a variable called array. And finally, I have a print statement to output my array value. Alright, let me run this code block, and I just get an array of numbers, as expected. So nothing too fancy here yet, but this is the foundational block of NumPy. Now let's build on top of that. NumPy has a feature called broadcasting. This is a powerful mechanism in NumPy that allows you to perform arithmetic operations on arrays of different shapes and sizes without the need for explicit looping or reshaping. So let me show you the next code example. I start with a typical import statement since I want to use the NumPy library, and I alias it with just np. Then I have two arrays, array A and array B. Array A, as you can see, contains the integers 1, 2, and 3, while array B contains the integers 4, 5, and 6. Then on the next line, I have C equals A times B. So I'm taking each item in array A and multiplying it by each of its respective item in array B. So the 1, which is the first item in this array, would be multiplied by 4, which is also the first item in the other array. Then the 2 times 5 and the 3 times 6. All this multiplication will happen in the background and it will be very quick. Then the next line of code, I have D equals A times 3. So I'm taking each item in the A array and multiplying them by 3. Then I have a couple of print statements to see what the output is for this code block. So let me run this and see what happens. As expected, the print C statement returns an array of 4, 10, and 18, which are the correct values, and the print D statement returns an array of 3, 6, and 9, which are also the correct values. So this is a glimpse of how powerful this library is in working with numbers and eventually data. If I wanted to do the same functionality in straight Python, I would have to create a loop to iterate through the different items. However, with NumPy, it's quicker and more efficient. But let's not stop here. NumPy also provides a comprehensive set of mathematical functions that can be applied element-wise to arrays, or used for more complex operations. These functions include basic arithmetic operations, trigonometric and logarithmic functions, linear algebra, and statistical operations. So let's review the next example. I have my import statement. Then I create a NumPy array of 5 integers and assign it a variable called a. On my next line, I call the sum method of NumPy and pass it my a variable, and I assign this value to a variable called b. Then I just print out b to see what my output is. So let me run this code block. And my output is 15. So through one simple method call, on one line of code, I was able to sum up all the array items. Other cool features of NumPy are indexing and slicing. NumPy provides advanced indexing and slicing options, allowing you to extract specific elements, rows, or columns from arrays, as well as perform more complex selections based on your specific needs and conditions. Let's look at our next example. I have my usual import statement. Then I follow it with a multi-dimensional array. It's basically an array of arrays. And this will create for me a 3x3 table. So 3 rows by 3 columns. And I assign this array to the variable a. Now, based on the rule of indexing, the 1, 2, 3 array would be index 0. Then the array containing 4, 5, 6 would be index 1, and array 7, 8, 9 would be index 2. And each of these arrays would form a row in my table. So on my next line, I can call the first row of my table by using this syntax. The name of my NumPy array, which in this case is just a, followed by the index of 0. Then I assign this to a variable called first_row. Of course, I can change the index value to get the second and third rows, but for this example, I'm calling the first row of data, so I use index 0. Now, how about if I want to get columns instead of rows? For that, I can use the slicing notation. So on my next line of code, I again have the name of my NumPy array, which is a. Then I use the square brackets, and inside of it, I have a colon, then a comma, then the number 1. The colon is basically saying to use all items from start to end. Then the number 1 after the comma is saying to return the index 1 item of each array. So that would be items 2, 5, and 8. I then have some print statements to show us the outputs. The first print statement is to show us how the multi-dimensional array looks like, which, as I mentioned before, it's a 3x3 table. I also added the end attribute so I can leave a blank line after the print statement. Then the next print statement will show us the first row in that table, and the last print statement will show us the items in the second column of our table. So let me run this code, and there we go. Here I have my 3x3 table, followed by the first row of 1, 2, 3, and then I have my first column data, which are 2, 5, and 8. NumPy also includes a random module that allows you to generate random numbers, create random arrays, and perform random sampling from probability distributions. Here's a quick and simple example. By now, you are familiar with the import statement, and my next line of code is where I call the rand method of the random object in NumPy. I then pass it the numbers of rows and columns, and in this particular example, I'm creating a grid of 3 rows by 4 columns, and the items will be random values between 0 and 1. Then I assign this to a variable called random_array, and finally, I print out this variable to see my output. So let me run this now. And as you can see, my output is a 3x3 array, all populated with random numbers between the values of 0 and 1. And if I wanted more arrays, I can specify the count as my first number item, so I'll type a 3. And by adding a 3 as my first argument, I now will get 3 random multi-dimensional arrays. So let me run this code to verify this. And there we go. Okay, and now we come to the assignment part of the week 3. And as you can see here, this is the assignment description from our class. And as usual, it's broken up into 2 sections. We have the Python section, and then we have the R section. Now I will be covering the Python section for you step by step, and then I ask you to complete the R section on your own. So basically the assignment is asking us to use data from a text file, which I've already opened up here. So it's just basically 4 rows, and it's basically revenue data, revenue from the East region, revenue from the South, West, and Midwest, and then these are the individual data points. And so I also took the liberty to write the code so you don't have to see me writing it in front of you and wasting some time. So basically we are going to be using the numpy library. Now just in case if you don't have numpy installed, you basically just need to go to a command line or a terminal. And then in Python we use the pip command. Now it could be pip or pip3 depending on which version you have installed. So let's just assume it's regular pip. And then we say install, and then we followed by the name of the library. So in this case it's numpy, and then we hit enter. Okay, now in my case I got pip is not found, so I'm going to try pip3 followed by install numpy, hit enter. Alright, and based on this already says that requirement already satisfied. That means I already have it installed. Okay, but in case if you did not have it installed, you will see some downloading and installing happening. Alright, so now that I know I have numpy installed, I can go back to my code, and now I can import numpy because numpy has been installed, so I could use it. Now the as is basically an aliasing keyword in Python, so instead of using the word numpy every single time, I could just shorten it with np. You can call it np, you can call it anything you want, but again, traditionally most Python programmers, they alias numpy with np. Then the next step is to basically start creating my arrays, and I call the np object, and within numpy there is a method called array, and within this array I pass it the list of my data. Now again, all this data is basically from this file. Okay, I just basically recreated it. Of course there is a simpler way, well technically maybe not simple right now, but we can import data from text files or CSV files so we can use them in our programming application. But to make matters simple for now, we're just going to hard code the values from the CSV file. So once you have this built, again, you're going to create an array for revenue east, an array for revenue south, and one for revenue west and midwest. Okay, and the way we do it again is you call the np, which is the numpy object, again aliased as np, followed by the dot notation, followed by the array method, which is one of the main methods in the numpy library, and then we pass it the data that we want to use in our array. Again, array is the same thing as list. Okay, now once we have those values, again, I like to print things out so I can see what I'm getting back. All right, and I'm ending the very last one. Well, it's a print statement, and I'm basically going to include a string that says revenue midwest followed by a colon, and then I'm going to append to it the value of whatever revenue midwest holds, and then at the end I'm going to include the end attribute, and the end attribute basically all it does is it customizes how I want the last line to behave. So here I'm adding basically 3 new lines. Okay, and I'm doing that just for cosmetic purposes, so when I come to the next print statements, there is going to be some spaces between this print statements block and then this print statement block. Okay, so again, so far all I did is I just hard-coded all my arrays, created my arrays, the 4 of them, and then I'm going to print them out to see what I'm getting back, just to confirm that my data is correct. And the next thing is, well, according to the assignment, it says, well, you need to determine which one has the highest total revenue array. Okay, so basically there is a sum method that's also part of numpy, and the sum method takes an argument, and the argument is basically your list or your array. So I'm going to pass revenue east to the sum method. I'm going to pass revenue south to the sum method. I'm going to pass revenue west and revenue midwest also to the sum method. And then when it comes down to the very last one, I'm going to include an end attribute so I could make some spaces between these print statements and the next print statements. Okay. So the array method creates the array. The sum method can basically total the entire numbers or the entire items for us in just using the sum method. Okay, and it says determine which array has the highest total revenue. Once you do all this, you're going to realize that since I'm printing them out, you're going to realize that this number, the sum of the revenue midwest, does have the highest total revenue. The next code block is basically going to say we need to find the maximum individual revenue value among all the arrays. Okay, well, basically what that means is if you look at this array, okay, there's a lot of numbers in it. Now which one is the highest? Let's capture that. And now let's capture the highest number in this array, as well as capture the highest in this array, and then capture the highest in this array. All right, so in numpy there's another method called max. Okay, max basically, as the name implies, is going to give us the maximum value of this array. So I'm going to call the numpy, again np alias dot notation. I'm going to call the max method, which is part of numpy, and then pass it an argument, which is my data, which is my array. This is going to return the maximum value in this array. Then I'm going to do the same for all 4. Okay, again, last one is going to end with this. Now, once you have the results printed out, you're going to see that this one, revenue midwest, has the largest single, which I guess is going to be this number. Again, I know this data because I've worked on it while I was building this assignment. So 890 is the highest, not just in this array, but also the other 3 arrays. Okay, there is no number higher than 890. But, don't take my word for it. The code is going to tell us in just a moment once I run it. Okay, so max, that's exactly what it does. It gets the maximum value, and as you can guess, min is the minimum value. But right now it's asking to get the highest individual revenue. So I got the highest for each one of them, and then when you compare all 4, you're going to see that this one is the highest. Then the next requirement in the assignment is, once we know what the maximum is, it wants to know where in the array is this location. So again, this is it here. So this is index location, what is it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it should be index location 12 inside the revenue midwest array. Okay, and that's what the code here is going to do. So the max method gives us the highest number, but argmax, arg is argument max, is going to give us not the maximum value, but the location of the maximum value. Okay, so that's another method that we can use also in numpy. Now notice that all these things, we can technically do them with lists, but it's going to take a lot of steps. So numpy streamlines all these steps for us by importing the numpy library. Next thing is add each corresponding row in each array and then place result into a new one-dimensional new array called total. So the assignment wants us to now create a new array and basically include the total or the sums of each revenue line in that array. Okay, so I'm going to create a new variable called total. Inside this total, I'm going to assign it. Let me just make some breathing space here. I'm going to assign it. It's going to be a new array, and the new array is going to contain the sum of each of the 4 individual arrays. So I'm going to have np.sum. Technically, I think I had them up here. Okay, so since I didn't have a variable name for this, I'm technically creating them again from scratch. So the first item in my array, in my total array, is going to be the sum of revenue east. Then the second item is going to be the sum of revenue south, and so on and so on. So I'm going to have 4 total revenues in this new single array. All right, then I'm going to print it out just to confirm that the data is what I think it is. Then I need to get the grand total revenue. Okay, so I need to get the total of this total array. So the total array right now basically just has 4 sum values. Now I want to get the sum of these 4 sum values, and that's what I will be doing down here. I'm going to call the sum method of my numpy array and pass it the total array, which is this guy here, which has all 4 sums. So now that I have the 4 sums, I'm going to total them using the sum of my total array. That's going to give me the value of all the 4 arrays combined together. Then the assignment is going to ask us to do or to generate random numbers. Now, random is another method, or technically it's also a class in the numpy library, and there are different random types. There is normal and there is uniform. And there is also more, but for the assignment is asking us to do a normal random generation of numbers and a uniform random generation of numbers. So the first one, it says, let's create an array called costs1 that contains 5,000 random generated values, and that random generation needs to follow a normal distribution that has a mean of 300 and a standard deviation of 30. So again, NumPy is all about mathematical equations, mathematical calculations, as well as statistical analysis. So mean and standard deviation are basically at the heart of any statistical analysis task. So within the NumPy library, there's a random class, and inside the random class, there's a normal method. The normal method takes 3 arguments. The first argument is the mean value, followed by the standard deviation, followed by the size or the number of values that you want to generate. Okay, so I've created this code, and the value is going to be stored in a variable called costs1, just as per the assignment instructions. Then I'm going to print it out to see exactly what this costs1 is. All right, and then the next instruction is whatever I get back from costs1, I need to round those values to 2 decimal spaces or 2 decimal points. Now, when you get back this value costs, it's going to be a list of numbers. They're going to be floats, and they are going to be multiple numbers after the decimal space. So we need to round it, because again, NumPy also has a round method which takes 2 arguments. You have to give it the value that you want to round, and then you have to tell it, well, how many spaces in the decimal spots do you want to round it by. So this line of code is going to do exactly that, round each number to 2 places past the decimal. All right, and then the last thing in this costs1 requirement is that we need to sort it. Okay, so sort the array from smallest to largest value. And luckily, in NumPy, there is also a sort method. So I'm going to call a sort method from my NumPy object, and I'm going to pass it the values or the array that I want to sort. So I'm going to sort costs1, and I'm going to display it here and see what I get back. And again, I'm going to be ending it with 3 new lines, just so I could leave some spaces between this print statement and the next print statement. Then it asks us for costs1, we need to do some statistical analysis by calculating the mean, the standard deviation, the median, the min, and max value. Okay, and again, in NumPy, this is very simple because there is a method called mean, there's a method called standard deviation, and there's a method for median, as well as min and max. Okay, so again, don't have to reinvent the wheel. The methods are there, we just have to call them and pass them the information that we need to calculate all these calculations for. So that's pretty much it for costs 1. Now for costs 2, we need to do pretty much the same thing, but instead of getting a normal random generation, we want to do a uniform random generation for our distribution. And it wants to specify the range, meaning we want to use numbers from 210 to 390. And code-wise, it's very simple to the random normal distribution. Again, it's np.random, but instead of .normal, I'm going to call the uniform method. And again, it takes 3 arguments. They're a little bit different. This is for low value, this is for the high value, and this is for the number of values that we want to randomly generate. Notice how here I have low equals 210 and high equals 390, again, based on the instructions here. You don't have to specify these words. You can if you want to, but you can also erase this and just put the values as is. And the Python interpreter is smart enough to know that, okay, the first argument is going to be my low, the second argument is going to be my high, and the third argument is going to be my size or the number of values that I want to generate. Okay, and then I print it out just like I did before for the costs 1. And again, I need to sort my costs 2. So again, I'm going to call the sort method from my numpy class and then pass it the data that I want to sort. And then I'm going to print it out to see exactly what I get back. And then follow exactly the same steps by doing some statistical analysis, calculate the mean, standard deviation, median, min and max, but this time on costs 2 array. So now is the moment of truth. Let's run all this code and see what we get back. I'm going to do F5. Alright, so let me go to the top and see exactly what we get. And let's see if I could push this to the back. Okay. Alright, so my first set of print statements is I'm just going to be printing out the 4 arrays that I created here. I'm just printing them out. And so I do see the arrays correctly created. The next thing is I need to get the totals of each one. So totals basically is using the sum method. So if you add all these numbers, you're going to get 3,154. If you add all these numbers, you're going to get this. If you add this and these numbers, you're going to get that, and so on. Okay, so these are the totals using the sum method. Then I'm going to get the max value from each number, or from each array, I'm sorry. And the max basically is going to be using the max method for each array. So for example, it says 291 for revenue east. So let's see, is there anything higher than 291? Here's 291. Okay, nothing seems to be higher. Okay, so the max method did its job very quickly. And then for the revenue Midwest, again, because I know the data, this is the highest number. So the revenue east, the highest number is 291. The revenue south has the highest number, 445, and the highest number for revenue west is 694, and the highest revenue number for Midwest is 890. So 890 is the highest of all 4, making it this the highest individual revenue item in my 4 arrays. And the index location of the highest value in revenue Midwest is 12, because again, index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so index 12 is the location of the highest revenue item for revenue Midwest. And then we created a new total array, and the total array basically, let me pull this a little bit down, the new total array has the 4 sum values, which is, oops, there we go, which is 3154, here it is, 444992, here it is, 7294, here it is, and 9910, here it is. Okay, so this was basically this code here, creating the 4 totals in one array. And then we took these 4 numbers and then we added them together using the sum method down here. Well, let's see. Okay, so if you think 3 plus 4, that's about 7, 14, and that's 24, and give some, yeah, so 25,350 sounds about right as a total for these 4 numbers. Okay, then we went to the normal distribution and the random normal distribution and the uniform random distribution. So cost1 was the first one, and basically I created 5,000 items. Now it's not going to display 5,000 items for me here, but it uses the ... which basically says, okay, so here are the first few numbers, and then here are the last few numbers. Okay, so it gave me 3 numbers in the beginning and then 3 numbers at the end. Okay, now notice that these numbers, so the first one is 334 dot all these decimals, and the same thing also with the next number, all these decimals, and then every number has a lot of decimals. But the next step was to round to just 2 decimals. So that's what I did. I took the 33459 blah blah blah. It shrunk it down, rounding it to just 2 decimal points. 2 decimal points, 2 decimal points. So the same exact numbers have been rounded down to 2 decimal points. Okay, and again the ... meaning that these are the first 3 numbers, these are the last 3 numbers, and the middle numbers are just, it's too much to write 5,000 numbers on the display. And once we did that, we also did the sorting. So I took all these values and I sorted them from smallest to biggest. So again, 198 is smaller than 205, which is smaller than 207, which is smaller than 393, and so on. So you can see that these numbers have been sorted in smallest to largest. And then the results of the statistical analysis: the mean for cost1 is this, standard deviation is that, median is this, min and max are these 2. All right, and the same exact thing now for costs 2. We got the random values. Here are the return. Again, out of the 5,000, I got the first 3 and the last 3. And again, the decimal spots are, well, actually it didn't ask me to round the decimal spots here, but it did ask me to sort them. So I did sort them, and you can see from smallest to biggest, we started with 210 with a lot of the decimals here, and then we finished at 389. And then the same thing, we did some statistical analysis, and here they are. That pretty much wraps up the coding part. Now the assignment also is asking us to briefly discuss the difference between costs1 and cost2, especially as related to the mean, median, and standard deviation values. So basically costs1 follows a normal distribution with specified mean and standard deviation. Again, it was given to us. Cost2 follows a uniform distribution over a specified range. So in a normal distribution, values cluster around the mean, leading to a higher frequency of values that are near the center, and fewer values are at the extremes, which results in a bell curve shape. Maybe you've seen that before. Now, in a uniform distribution, values are spread evenly across the range, leading to a flatter distribution where each value has an approximately equal chance of occurring. So costs1 will have more values around the mean, and costs2 will have a more even spread. And the mean and median in a normal distribution are close due to the symmetry, whereas in a uniform distribution, they are roughly the midpoint of the range. As for the standard deviation in a normal distribution, it is derived from the spread around the mean, but in a uniform distribution, it depends on the range, and it's generally, or usually, it's lower. So please write up something similar to what I just discussed at the bottom of your code file here, writing it as a comment. And speaking of comments, please don't forget to include comments in your code. Again, it's part of best programming practices to comment your code. Alright, so that wraps up this video. Please let me know if you have any questions, and thank you for watching. Take care, and bye for now.